Good morning. Welcome, everybody. Nice to see so many people here. We are here to talk about self-charging batteries. So let's get started. I'm Klas. I'm working for a company called Nichicon, and I'm responsible for sales of batteries in Europe.
And my name is Jonas Engstrand. I'm a senior account executive at Epishine, a Swedish company who makes indoor solar cells like these. So, Björn.
Good morning. My name is Björn Rosqvist. I'm a Chief Product Officer at Qoitech, and we make tools for power optimization and battery profiling emulation and also PV cell emulation.
Very good. So this is the agenda for today. So I will be talking about energy harvesting, why this is important, and I would also give you a brief explanation about our concept of self-charging batteries.
And I will continue with the hardware concept of it all to showcase how we have built this device and what the upsides are and what to expect from it.
Yeah, and I will take the last part, talk about how you evaluate the system and see that it works as you expected.
And at the end of the session, so we reserve some time for you to place questions to us, and we will share contact details with you also on that last slide. And you're welcome also to come down to our two booths down in the hall later to talk more with us if you like to do that. So let's start talking about energy harvesting. So why we think this is important and why we have come up with a solution for energy harvesting. So a scientific definition of this is to harvest energy, ambient energy, of various sources and turn this into electrical energy to power electronic devices, to make them self-powered and energy autonomous. Normal ways of powering electronic devices would be mainly these three listed on the top. So either you could use replaceable batteries, you could use rechargeable batteries, or you could of course also cable things to an AC outlet. Talking about batteries, we'll give some numbers to you here on the screen. So this is a massive market, and there are many problems with this. So annually, there seems to be a production output in the world about 10 billion alkaline batteries. And in addition to this, there are approximately 5 billion coin cell batteries produced every year also. These batteries have limited lifetime, and dependent on the use case and the battery type, they may be already at the end of the lifetime in a few years already. And with these kind of numbers, that is obviously a problem for sustainability. And even in Europe, where we are quite good at recycling and collecting waste batteries, only 50% of the batteries are coming back after usage. So other places on the planet may be even lower numbers than that. So this is also one thing that we want to tackle with our concept of self-charging batteries. If you have replaceable batteries, that is of course a big issue because it takes time to replace batteries. You need to send service engineers out in the field to replace batteries, and this has of course a lot of cost in total cost of ownership. If you would have rechargeable batteries, that is also something you need to manage. So you need to get the devices to charging pods, and that is not always a good solution either. And the last option of cabled solutions is of course a high invest in the installation early stage, but not only that, that is also compared to battery-driven solutions, of course, constrained in terms of where it can be placed and how far away from an energy source. So what we have come up with is to harvest energy out of ambient light. And we are doing this together with the company Epishine, which is specialized in harvesting ambient indoor light with an organic PV cell. And we want to help you and help the world and the market to power electronic devices with this without using billions of disposable batteries. And at the end of the day, we want to realize energy autonomous products for you. So our concept of self-charging batteries, we want to make things more simple for engineers. So having tried to promote our batteries, and I think I speak also for Epishine, promoting their product is not always that easy, because the time to market takes time, and all of you have limited time, and to set up a solution with energy harvesting isn't always easy, and it may not always happen. So we want to prepare a concept for you where you can more easily get started with this. And at the end of the day, for the market, this should realize a lower cost of ownership, total cost of ownership over the time, and it should also help to save the planet. So this is the relevance and the purpose behind this. The technical advantage of this is that we have made well thought through thoughts in the components used. They are all matching very well together, and this will help you to realize a good product in a very short time. And the commercial benefits of this is that you do not need to spend time and money on the development of this concept, and we can also bundle volumes. So for small and medium-sized companies, it may be relatively expensive to realize these kind of solutions, and with the help of bundling one common solution for many companies, that could also help to lower the cost of this. And also with the help of Qoitech, we can also minimize design margins in this concept by knowing the products used from both manufacturers. And at the end of the day, we want to then get rid of disposable batteries, and we want to help you to accelerate the adoption of IoT and do something good for the planet. So I will hand over to Jonas.
Yeah, thank you. So I will speak a bit more about the hardware concept itself, and also a bit more in depth, like why we did this and how to proceed. So what is based out of the components going into this product is basically our PV cell, as you see there. I also have one in my pocket. It looks like this, very thin and flexible, so you can have a very, very slim format of your IoT device. You have black masking to make it as good looking as possible, so you can actually just stick this onto a chassis, for example, and just have the FPC cable going through. So you can actually make an IoT device energy self-sufficient with a very easy, very easy way. And then we have an FPC cable, as you can see here, that is going into the patches of the solar cell, and then you have a discrete solution using an overprotection and underprotection of the battery. So it's the good thing about our solar cell together with Nichicon battery is that our solar cell's behavior with 5 cells is really a good match for the Nichicon battery's charge and discharge curve. So that's the complete solution in that sense. So the concept is that we have a plug-and-play solution for you guys to actually start using energy harvesting in a faster and easier way, because we know from a couple of years into this that it always takes some time to actually make the product, to have the R&D done, and then also to launch the product itself. So cutting, I would say, up to a year, I would say, in R&D you can do with this product. So it's a solder-free assembly. It connects directly with a board-to-board connector. And yeah, the complete idea is to eliminate the need for disposable batteries. And also going into a bit more what Klas already told, is that the TCO for the end customers, such as facility owners and management companies, that's really high for replacing batteries, going from 30 quid up to 100 quid per battery replacement. So it's not only the sustainability, it's also the cost of it all. The distinguishing feature is that it's a simple, cost-effective electronics. Yeah, as I said, shorter time to market, and it's sustainable. So what you can expect is that you have 457 microwatts output power from the solar cell at 500 lux, which is roughly what you have on your desk in your office. You have the 4 milliamp hour LTO battery from Nichicon, which has a 20C deliverance, so you can give peak currents up to 80 milliamps. Short intervals, and you have a discrete solution chip. So just showcasing something here is that if you compare this to a CR 2032 coin cell, which has 250 milliamp hours, just having 8 hours of light in a typical office environment, you will actually replace 10 coin cell replacements during 10-year period. And then, yeah, we have a data sheet that you come and have a look at our booth and just pick it up, and you can see the schematics of it all and also the output that you have. Yeah, I think it's time for you to go.
Thank you, Jonas. Okay, so now you have the system, but does it really work? Does it fulfill all the demands that you put on it? So it's always good to start with the highest level. Looking in the data sheet, you have seen the data sheets. If the sensor is going to be outdoor, make sure that it can handle the cold climate, of course. Looking at the different batteries, some batteries you're not allowed to charge in negative temperatures. So then, if it is like in Sweden, a cold winter, then the sensor will die during the winter time because you're not allowed to charge it during the winter time. Like with Nichicon batteries, that's not a problem since it can be charged in cold climate. So the top level is to look into the data sheet as a starting point because this will be important. Then looking in piece by piece, looking into the battery. With our tool, it's possible to discharge the battery to create a battery profile of how the battery works. Of course, also here it will be important to look into the different temperature because the battery will behave differently. It will have a much higher internal resistance in cold climate. So make sure that you test in all these environmental conditions that your device will be subjected to. The step after that is now you have the data about the battery, how it looks like. So then you can then emulate the battery. Emulate the battery and see how it works in the system. You will be able to see any problems. You will be able to see how much of the battery capacity you actually can use. So you don't design a battery that you only utilize 50% of the possible capacity. Then looking into the next component, the PV cell. You have the data sheet, you have the data, how the IV curves, how much energy you can get from the cell. In your particular use case, maybe it will not be mounted exactly in the right angle. The sun or the ceiling light will maybe come into a different angle. So then make sure that you measure the possibility that the cell can give. Measure the real energy that you can get from the cell. So plot the IV curves, get all the data from the real device. And third component, PMIC, Power Management IC. Do the measurement of this, see the efficiency, so you don't waste energy in bad efficiency. Check the efficiency between the PV cell to the storage, but also the storage to your IoT device. Make sure that it is a good PMIC, good efficiency for your device. And also make sure that you have the right settings so you can utilize the full energy of the battery. If you have the wrong settings, like when is the battery fully charged, when you are not allowed to charge anymore, or when is it too low energy for the device to work, make sure that you test all these limits. And all of this maybe doesn't really matter, or if your device, if it's not optimized, energy optimized. If you have a low energy device, if you have been working with optimizing it, then it gives you much more freedom in the design. If you consume very little energy, then you will have more possibilities in selecting batteries, PV cells, and so on. There is a lot of possibilities to optimize, look in different behaviors of the of the device. So make sure that it is fully optimized. Yeah, quickly what I talked about. Start with looking at the energy storage. Look into the PV cell, make sure that this is the best selection. Look into the PMIC, but very important is to then optimize and know your IoT device, so it is best efficiency.
Very good. So we have come to the last slide, which is Q&A. So we are here to answer your questions. So please let us know what more there is we can tell you about this. Please.
Just a quick question. Hello. Hello. Can you hear me?
Yes.
Just a quick question about what kind of things can actually degrade the battery in terms of like a salty water or something like that. Do you have any things apart from the cold in Sweden that can affect the batteries?
So the battery that we have in this setup of the self-charging battery is a very durable battery, a very robust battery technology. So if you use that in a reasonable way, it will actually not degrade too much over time. It has a capability to withstand 20, 30 thousands of complete charge-discharge cycles over time, and still it would offer you 80% of the capacitance after this. It can also withstand very high discharge current consumption. So Jonas mentioned it earlier, so continuously 20C, so that is 80 milliamp for this small battery that is integrated here. And for short term, you can even get 100 times the capacitance out of this energy storage. That would mean 400 milliamp. So it is supposed to be a very robust solution for you that should not degrade actually. We are talking about 10 years in the field.
Yeah, and I think just to emphasize, it's intended for the indoor usage to begin with, so salty water wouldn't be an issue in that sense. But of course, yeah, it's a very durable solution for the indoor applications. Water shouldn't be an issue either in that sense. But yeah,
you're welcome. Please.
Thank you. This may be a naive question, but I'm pretty sure Nichicon make capacitors. So why batteries rather than sort of supercapacitors?
So yeah, it is correct. So Nichicon is well known for capacitors. We have been producing aluminum capacitors since decades, and we actually also have production of supercapacitors. We have come to the technology of battery because we have found a partnership with another Japanese company called Toshiba. So we are using actually their battery electrode technology, and we are profiting from our decade-long experience in the assembly process. So you can have a look later here. This is the lineup of batteries. They look like capacitors actually. So the production procedure is very similar to when we produce capacitors. So that's our natural way into this. And the mission statement of Nichicon is also to really try to do something good for sustainability and a greener planet. And we believe that this battery thing is a very important point. So it also matches to our mission statement as a corporation.
Thanks. The battery that you showed there in the integrated solution was 4 milliamp hours, right? Is there a range of battery sizes available? And sorry, follow-up question would be if we're looking at a constant power consumption that's something in the region of like maybe 1 milliamp or something like that. I'm basically wondering if there's a PV cell and battery combo that can basically sustain that kind of continuous usage at a relatively high proportion of the battery's total capacity.
So for the self-charging battery concept as of today, we have decided to set up only one combination of size of PV cell and the battery. So there you can do the math then to see if what you can consume. In terms of the battery capability itself, there is no problem to continuously consume such power. That wouldn't be the problem. And
and to have that charged, it's just a matter of how large solar cell you would need then.
Yeah.
So of course that will be done. Yeah, so the size of the solar cell can be customized from Epishine. It's we have a lot of different varieties of solar cells depending on both the customer but also the application itself. So if you look at the remote controllers, for example, you only need about 10 square centimeters. If you look at a typical IoT device such as temperature humidity sensor or C2 sensor, the size that you have here, a 50 by 50 mil, it's enough to power it. But of course, it's depending on how often you need to transmit data. And that's also a thing about energy harvesting, I would say, is to understand also how much data do you actually need and what can you, instead of measure towards a reference point, let's say if you have temperature-wise, you have 21 degrees in a room, then you have an interval between plus minus 0.5 degrees. If it's in between there, you still measure, but if it's not below or above, you don't transmit. Then you save a lot of energy in that sense. So making smart IoT devices also enables energy harvesting and then not needing to replacing batteries.
So to give you maybe a practicable example for this one, you can come down later to our booth just next to the entrance of the show, and you will see this one hooked up with the nice equipment of Qoitech. And what we are emulating there continuously over the whole show with normal indoor light here, that is actually to every second minute we consume the power of transmitting LoRa. Every second minute. And we remain on a constant charging level on the battery with this cell.
Yeah, and then you have roughly 500 lux in this kind of environment here in the fair. So it's normally what you have on your desk in your office then. So then that's possible to actually transmit that often.
Yeah.
Yeah.
Yeah, so it's very easy to do this test to see how often can you transmit, how much data can you transmit in the different conditions to see if you have a net positive energy flow or net negative.
If you put that solar panel behind a tamper-proof environment where it gets, scratched and degrades. Sorry, if you put the solar panel behind a tamper-proof environment where it's likely to get scratched and damaged, do you have any data about how that affects the performance?
We haven't tried out that specific application, but we have run a lot of accelerated testing, both with temperature-wise and also humidity-wise, not for like scratching in that sense. We do, however, have a concept for a remote controller where you can actually have a push-through solutions. You have dome buttons underneath the solar cell, and then just push through the solar cell more or less onto the button, and that we have run 550,000 pushes, and there's still no damage on the solar cell in that sense. So it's very durable in that sense.
And as shown previously, it is very easy. I mean, if you put a PV cell behind something and you scratch it, it's very simple to do measurement yourself to see how much it degrades, and you can compare these measurements.
But I would say scratching it wouldn't be an issue. You will still have a lot of light going in, and due to it being more or less just a piece of plastic, more or less, it endures quite a lot if you compare to glass variants.
It's maybe more discussion point rather than a question, but I've done quite a lot of work on energy harvesting and replacing batteries and so on, and I always get the pushback on costs because the cost of the energy harvester, the chip, and the actual storage is a lot more than just a coin cell that you drop in, and manufacturers, on top of that, they don't really care because it's the user at the end of the day that replaces the battery. So I just wonder if you had any thought on that, and how do you tackle that problem here, like the actual commercial aspect?
Yeah, so we're trying to work very closely together, all the 3 different parts that's needed for the energy harvesting to actually come down quite a lot on the costs. We have done some great progress, I would say, in the last 2 or 3 years. Still, it is a bit more expensive than just having a coin cell or a AA, AAA. But the thing is that you need to promote TCO. So especially if you look at PropTech, for example, and you have temperature, humidity, CO2 sensors that goes out to facility owners and management companies, they will care about the TCO because it will cost them around 30 quid up to 100 quid to actually replace batteries. And if you have, like, let's say 100 or 500 sensors in a building, that is a substantial amount that you can actually save. But then you actually need to promote that and showcase that that's the case. So yeah, it is a bit difficult to actually convince the procurement guys that they should purchase something that is slightly more costly, but over 10 years time, it will save you 3 times the price.
But it is a relevant point, and we actually also struggle with the same thing that you explained, that there are always different decision makers, and the one that decides what is going to be bought is not necessarily the one that cares for total cost of ownership. So it is something we struggle with, and there are, of course, markets and products that are more likely to be viewed as a total cost of ownership, so where energy harvesting may more easily be adopted. But it is difficult sometimes, but as mentioned during the presentation, especially for small and medium-sized companies, we trust that by doing this and bundling this, at least we can offer this to such clients in a much more cost-effective way, and maybe make it easier for adoption. And I think also at the end of the day, what the market needs to start doing in a better way is to feel confident about the lifetime and durability of products. So when you look at battery products nowadays, so maybe 10, 15 years ago on mobile phones, they were always specified with the lifetime. So standby time in hours and talking time in hours, that was a specification. Nowadays, there is no specification for battery life. And the only thing you see is up to 2 years. Very good, I know. Maybe if I'm lucky, it can live for 2 years, but it could also be 2 weeks. So there is actually no information, and that's where a company Qoitech comes in, because they can profile all of this and help you to be confident about what your product can actually do. Of course, you need to define certain environment for the market, but if you do that properly, I think it's also easier for the market to adopt energy harvesting.
Yeah, and as you say, if you just look at a data sheet of a sensor, as you say, it says up to 5 years, up to 10 years, but that completely depends on the SF level that you have and where it's placed, how often you transmit and everything. So most of the customers that I talk to, when they have a device that should last 5 years, they say, typically it lasts 2 years or 2.5, and just to either we can extend the battery lifetime by using energy harvesting, or we can even make it self-sustained in that sense. But it comes with the boundary condition that you need to have enough lighting or a large enough solar cell in that sense. But coming into the price, again, it's always about the volumes also, like how many devices, how many solar cells from our side will this company purchase? And then we can give a lower price, of course. And also scaling up our process is based on a roll-to-roll production process. So more or less like a newspaper printer. So just making it wider will lower the cost quite a lot, also on the solar cell.
Yeah, and feel free to stop by our booth. You will see live demos of this. And of course, happy to talk more about power optimization in our booth. And
yeah,
you have the batteries and PV cells.
You have all the contact details here, so you can see the booth number. So Qoitech is down just below here, and we are back at the entrance of the show. And you have also email addresses to all 3 of us. So feel free to reach out to us also after the show.
Yeah, and we have live demos, so not static demos.
Yeah,
so.
yeah.
It's very fun because then you can just shade the thing and see what happens.
And scratch.
Thank you. Thank you so much.
Yeah, thank you very much.
Thank you.